Hi and welcome. I'm Gordon, and today we're going to be talking about safe isolation. We're going into more detail about safe isolation in a few moments, but let's get straight on with the PowerPoint. And as always, there's some important information I need to tell you about first. Remember, all the study material for this exam is now being done remotely. So when you go into the centres, you won't receive any more studying material from the tutors for this exam. Okay, so it means when you go into the centres, you need to have thoroughly studied for this exam remotely. Okay, because if you haven't, it's going to be very difficult for you to pass this exam. You're putting a lot more stress on yourself. So you can do that by revising many times, watching this video. Also look at all the other study material you've got, the Smart Skilling material, the Trades Jobs Mates material, and also all those great books you've got, which you've been studying using your TMAs. And as I've said many times, the beauty of this type of remote learning is you can watch this video, watch this lesson and all the other lessons we've recorded over and over again. You're not just getting a one-shot chance in that centre. If you're not quite sure on it, you can't go back and do that lesson again. This you can. So keep studying it over and over again, all those different types of materials. And don't underestimate the amount of material you've got to study. There's a lot to get through for you to give your best shot at passing these forthcoming exams when we get the centres open. So, as I said, we're going to be studying safe isolation today. And I'm just going to come out of the main screen in terms of, what is safe isolation. Some of you may have done this already if you've been in the centres. Some of you have probably studied it. In fact, you would have studied it already, even at the TMA 1. Safe isolation is a procedure which allows you to ensure the circuits you're working on are safe. It's as simple as that. You're isolating those circuits. Now, whether that's isolating an entire consumer unit or distribution board, or a specific circuit via an RCD, an RCBO, or an MCB, or a fuse for that matter. Okay. The key thing is when you're looking at the back of a socket, a light, a motor, whatever it may be, that power to that circuit is dead, and that's what we're ensuring. The Electricity Work Regulations Act actually specifically says, and you should never, let's say that in big letters, bold, underlined, never work on a circuit which is live unless it's extreme circumstances. And in my opinion, in a domestic scenario or a commercial scenario, which most of you guys are going to end up as, you should never work on a live scenario. It's laziness, ultimately. For argument's sake, I'll give you an example. If you're working in somebody's house and you're changing a light fitting in a bedroom, if you're careful, you could actually take that light fitting down and not touch the copper endings, and you could put that light fitting back together. But all it takes is one little slip of you casually touching one of those live conductors, and you're going to get an electric shock. Now, that in itself might not kill you, but you know what? If you're up a step ladder, you get that electric shock. It might give you such a shock, you fall off that step ladder and you bang your head somewhere. That might kill you. The difference is of you walking down those stairs, turning that circuit breaker off at the consumer unit and doing the safe isolation procedure. So when you change that light, you're completely safe. It takes a few minutes. And I think, and I'm sure you do, your life is worth more than a couple of minutes. Okay, so don't take that risk. I think if you've watched one of these videos before, I've mentioned in the UK, according to Health and Safety Executive last year, 26 people died through electric shocks. Over 15,000 fires occurred due to electricity going wrong in some form or another. And 1.2 million injuries occurred. Now, I'd admit not all of those were the result of somebody not doing safe isolation, but I think it just brings home how dangerous the industry we're in. Okay, it's a great industry. You can get a great living out of it. But the reason we get paid a lot of money, because there's that element of risk in there. Not everybody wants to do it, and not everybody can do it. But to keep yourself safe, okay, do safe isolation every single time. The only time you ever work live, and as I said, if you're doing domestic and commercial, you probably have never come across this, is where you see guys working in the road where there's a fault on the main sublines in the road or pavement. where they're actually doing reconnections. They sometimes work live, but if you look on them, they actually surround the entire area in insulating materials. They have insulating gloves on. Their tools are so insulated, far beyond anything you could buy in your local wholesaler. Okay, so don't attempt to work live. When you come to do your 2392, both your practical and your exam, it's a big emphasis on non-live working. Okay, part of the exam, it goes over and over again. What is safe isolation? What is the procedure of safe isolation? Get this in your head, because it'll be a big factor in you passing both the practical and the theory exam. Now, next week, we've got a test and inspection live training session as well, which I'm sure you're all booked onto, which we're going to go into more detail specifically on the health and safety, the safe isolation procedure and the test and inspection procedures for the exam itself. Okay, so this in conjunction with next week's ones will put you in really good stead to pass that exam when you go into the centre. It'll also help you do the practical as well. But just to re-emphasis on the practical side, when you do go into the centres, you will get help with that side of it from the tutors, but not for the theory exam. Okay, enough of me talking. Let's get on to the first presentation. As I said there, when working on an electrical equipment, it must always be isolated. Now, the definition according to the IET, now the IET, if you're not quite sure, that's the government regulation body which we all belong to. There's the guys who produce the regulations, BS 7671 and the on-site guide. Now, their definition of isolation, and I'm going to read it word for word, is a function intended to cut off for reasons of safety the supply from all or a discrete section of the installation by separating the installation or section from every source of electrical energy. Whoa, what a mouthful. The regulations is like that. Once you start studying those reg books, they're all in that really gobbledygook technical language. Bottom line, when you break that down, it basically means isolate, cutting off that supply from all of it, i.e. the whole consumer unit, or a discrete section, which means a single circuit, okay, from the supply or any source of supply. What do I mean by any source of supply? Just because your house or a house you're working on has a mains, which it all does, and that mains feeds your consumer unit, and you flick off that main switch, or indeed pull the main fuse or incoming fuse, there could be another source of supply. And I'm going to show you that and demonstrate it later. What I mean by separate supply, if you look at a lot of houses now, they have solar panels. That solar panel is another source of supply. That could be feeding a circuit breaker on that consumer unit. So as much as you've turned off the main incomer, there could be another supply in that consumer unit. Okay, so again, when you come into centres on the practical side, you'll be shown that. But from an exam point of view, it's worth bearing in mind there could be two sources of supply, even in a small domestic dwelling. Okay. Now, how we actually do this safe isolation procedure, I'm going to talk you through that. Then I've got a few questions I want you to answer. Then I've got a few little PowerPoints to go through what happens if you get injured via an electric shock, the procedures you need to go through. And then I'm going to attempt to do a live demo on this small board, and I've got one down here. So this is a single phase board, and I've got a three-phase board because they are slightly different. Okay, but the procedure is pretty much the same. Okay. So let's get going on that. So the equipment we're going to be using is an approved voltage indicator, a proving unit, a lock and key device of some description, and there's lots of them out there, warning notices and relevant PPE. So I'm just going to show you that one by one, what they are, or what I've got an example of. There's a voltage indicator. There's lots and lots of different types. This is the Fluke one. Doesn't mean it's any better or any worse. What it is, you've got two little tips. There are some safety features on there. The tips on there, if you look at the little tips on top, mustn't be more than 2 millimeters. It's got safety guards on here to stop your fingers sliding off, so you don't actually slide forward and hit one of the live terminals. There's internal fuses in here, so if you accidentally put this wrongly against a live supply and it blows up, it's only this going to blow up. It's cost you, I don't know, 20 quid, 30 quid. It's better this blowing up than some other piece of electrical equipment which might be more expensive. Okay, so the idea is You put this against a proving unit. A proving unit is basically an alternative source of supply, especially a box full of batteries, and putting the voltage indicator into these terminals here, it'll light up the voltage indicator. I'll just demonstrate that if I can. I'll show you. You see the lights coming on there? Take it off. Lights coming on. So what that's doing is proving this voltage indicator is in good working order. So when we pop that against the mains there, we know it's going to give us a good reading. So that's the voltage indicator and the proving unit. We also want a padlock to actually isolate the supply. And obviously with any good padlock, you get a key. On the padlock, we also put a warning notice. Okay, so that warning notice, a lot of them have a little space on there where you can put your name, date in this case, and a little point where you can put remarks on there, so you can say I'm working on the socket circuit. Obviously in a small house that bit doesn't really matter to a certain extent, because a lot of time it's probably just you working in there. However, the bigger the installation you get, where there's more and more electricians, that's a really good idea. If you're working in a small factory, for instance, and you're working on a production line for, I don't know, making sausages or something, you can write in there working on a motor on the sausage line. So if another electrician comes along and says he wants to turn this power on, he actually can see where you're working, go and find you and see if it's acceptable to turn it on again. Okay, so that gets attached onto there. And how we attach that on, we have various devices, which are basically little clips, and you clip these onto the circuit breaker or the incoming supply. Today we're using this particular one, so that I'll demonstrate at the end of the session how that works on. But in effect, that clips onto the circuit breaker. Your padlock goes through that particular hole. Okay, so that's what we're using. So that's your safe isolation kit. Every electrician will have one. You'll have it in your glove compartment or in your toolbox, wherever you may keep it, because you'll be using it a lot of times. Okay, it's a vital piece of kit. And that whole thing, I don't know, what's that, £50? Once you've got them, because the piece of kit, they're not going to get damaged in any way. It's not like a screwdriver, a hammer, where you're using it constantly and you're actually putting it under stress and force. They're delicate pieces of kit, shall we call it, and so keeping them safe in your glove compartment and then just pulling them out every now and then as and when you need them. So moving on, the safe isolation procedure, you'll see this written differently, different ways, looking, depending where you look, depending what book you read. All the Part P providers, Alexa, NIC, ECA, they'll have their own variations of it. But if you look in the regulations, and I think that's the starting point for anything we look at, they actually come up with this 10-point test procedure. Okay, so, and I'm going to go through these in more detail as we move through. But the procedure is, or the process in this case, first of all, you need to identify the means of isolation. What that means, you're going to isolate the cooker supply. Okay, obtain permission to isolate. It's so important to ask permission. Don't just go into a building, a house, and flick off a circuit breaker or flick off a main switch, because you don't know, just because that's now turned off the cooker supply, it might, well, if you turn off the main switch, it's going to turn off the entire house. I made a mistake many, many years ago, and it taught me a valuable lesson. I went to a house. The lady in the house told me, yeah, it's fine to go ahead. What she forgot, but her husband was upstairs in the office working on his computer, not saving his work. I went and turned the power off. It knocked off and he lost all his work, which he'd been working on all morning. You could imagine he was not a happy bunny. He was really furious with me, actually. Fortunately, because I said, well, your wife told me, it's like softened it a little bit, but it really taught me a key lesson. I always ask, not just to seek permission, but ask, is there anybody else working? It's a top tip when it comes to exams. One of the questions is always, what do you do first? It's always seek permission to turn off the supply. Okay, it's very, very important. Once you got permission, you can switch it off. You can then lock it off with a padlock. Always, always secure the key. When you finish with your key, that key goes in your pocket. Okay, always in your pocket. It doesn't sit on top of the consumer unit. You don't give it to your mate. If you got that key, that power supply can't be turned back on. And don't forget, it's you who are going to be working on that power supply. Okay, so it's in your interest to stick that in your pocket. Obviously, it's got a little lanyard, so I can put it around my head. Select the appropriate approved voltage indicator, which we've just seen. Test it on a known source. The known source in this case would be the proving unit. And then for single phase or three phase, it doesn't matter. You test between all live conductors, and then live conductors and neutral and earth. And then you retest the voltage indicator just in case it's gone faulty in the meantime. So we're going to go through step by step of all those procedures now. Now, as I said, there's different ways of looking at this. I don't know if you can see this quite well on screen because it's tiny writing, but it's like a bit more of a flow chart in that procedure. So it runs through what happens if you can't get permission. Then you can go back and say, well, you can't do the job. If you get to the point where you can't isolate it, well, you go back to the start of the job. So it's quite a nice little flow chart to read back. I'll let you read that in your own time because it's quite, like I say, it's quite small writing and there's a lot in there, but it's a very, very good thing to look at. As you said, the procedure for safe isolation comes in many, many forms. Right, so we're going to run through an isolation procedure for a domestic lighting circuit. So domestic means, if you didn't know, domestic means houses. Commercial means shops. Okay, so the first procedure we do, we check with the client. Is it okay to switch off that circuit? Have we got permission? Okay, also one good thing to do is outline, as it said there, outline the implications of safe isolation to the client. So in that scenario, I said, if I had said to that lady at that time, oh, by the way, when I turn the power off to the cooker circuit, all the power in the house is going to go off. Are there any other users in the house? I'd like to think at that point she would have said, yes, my husband's upstairs working. At that point, we could have told him, excuse me, we're going to turn the power off. Could you save your work? It wouldn't have been an issue. Okay, so I explain that. If you're working in a commercial environment, I've worked in supermarkets where I've had to turn power off to freezers. Obviously, in the implications of that, obviously their frozen food is potentially going to start getting damaged. It's going to have implications on their customers not being able to use the freezers. Okay, potentially it says there, then plan temporary arrangements. If in the supermarket, what we did in my case then, we ran temporary supplies from another consumer unit to the freezers. So even though we turned the power off, the freezers could still work. Okay, so it's not uncommon to do that. Again, in a house, probably wouldn't do that, but in a commercial premises, it's something you need to think about. So the isolation procedure, unplug any equipment, and then identify the circuit you're working on. I mentioned this earlier, when you're isolating the supply, just ensure there isn't any other known sources of supply. Okay, such as a UPS, uninterruptible power supply. That's basically a machine with batteries in, and it's designed, again, you wouldn't really get this in a domestic scenario, but in lots of commercial premises, offices, banks, even on the tills in supermarkets. If there is a power cut, the UPS kicks in. So in effect, the batteries take over from the power supply and still keep supplying that piece of kit with 230 volts. Now, if it had a UPS on a system, again, you didn't know about this, you went straight and start working on that till in a supermarket, you're going to get an electric shock. So isolate all known sources of supply. So what we do, we test the outgoing side of the means of isolation to make sure it's dead. Okay, so once we know that's dead, we can switch off the circuit, and that's just assuming we're just going to on a single circuit. What I'm going to be doing is taking the main isolator for the whole board. It doesn't really matter which you do; it's depending on what you're actually wanting to do. So isolation procedure. Once we know it's turned off, we then use a padlock and a notice to lock it off, put the label on, and keep the key in your pocket. We then test the voltage indicator against a known supply. Now that could be the actual main supply coming into the board because that's on the other side of the breaker. Okay, so we could do that, but most people use, as I said there, a proving unit. Once we've tested the voltage indicator, we know that's working, then we can do the test procedure. Now for a single phase, we go between live and neutral. live and earth, and neutral and earth. In reality, it doesn't matter which way you go around. You could go with neutral and earth. You could be earth and live and neutral at the end. It's no real. And if you look in any books, different teachers teach different ways. I'll show you my way at the end of it. But that doesn't mean that's the right way. Like I said, so long as you do all 3 points, it doesn't really matter which way you do it. But I'll show you my version, which I think there's a reason. There's a good reason why I do it that way, and I'll explain that at the end of the session. For a 3-phase board, instead of 3 tests or points of test, there's actually 10. And again, it doesn't really matter in theory what sequence you do it in. Again, I've got my way of doing it, which I'm used to doing it, and I do it in a certain way, and I know I haven't missed any of the 10 points. So once we've actually checked it, we then retest the voltage indicator, because you never know from initially when you tested it on the proving unit. Let's say, for instance, you dropped it and it broke something inside. So when you actually tested it against what you thought was a dead supply, it could be a live supply. It just means your voltage indicator isn't working. That's why we test it again, because if we now find the voltage indicator isn't working, we then have to go back and retest it, okay? Because it might be just a fault on the proving unit, it's just gone dead, or indeed it might be the voltage indicator. So what you think is now a dead circuit might actually be live. Once we've done that, we can actually switch off the supply and we can start work on the circuit. Right, let's have a quick few little questions and we'll see what you've remembered, and then we'll move on to the second part of the presentation before we do the live demo. As always with these questions and answers, I'll run through them at the end when we've finished them. There's only a few, only 4 questions, but these will be downloaded along with the answers when the recording gets put up on Student World in the next couple of days or so. Okay, and again, at that point, you'll then better keep going over them over again as part of your revision process. So what is the guidance for safety, GS, as it's referred to in industry, reference number for safe isolation procedure? Now, this was on one of the PowerPoints. Identify the function of a proving unit. What is the purpose of the proving unit? Proving unit is that little box of batteries as such. Question number 3, what is the most suitable location to isolate a live supply to a circuit in a domestic installation? And finally, which of the following is not a GS38 standard equipment for voltage indicators? And if you listened to me earlier, I actually went through 3 of these. Okay, so let's have a quick look at the answers, then we'll finish off the PowerPoint, then we'll do the live demo. So it should be coming up any second. Here we go. So what is the guidance for safety? The GS number for safe isolation equipment, it's GS38. Okay, GS38. So question number 1 would be A. Question number 2, the answer is D. Identify the function of a proving unit. It just proves that your voltage tester is working. Okay, that's all it proves. It doesn't prove but the main supply or anything like that. All it's doing is your voltage indicator, your voltage tester is actually working. And what's the most suitable location to isolate supply? Question number 3, it's C, at point of distribution of that circuit. What that actually means is if you're isolating one circuit, the cooker circuit, it's better just to isolate the 40 amp circuit breaker, MCB. Okay, if you want to isolate the whole consumer unit or distribution board, do it at the main isolator switch or the main RCD incomer. It's depending what you do, but it's the point of distribution. And finally, which isn't a GS38 standard requirement. Well, it's 10 millimeter exposed tips. If you remember, when I made a point of showing you these, I made a point of saying it's 2 millimeters. Obviously, you have 10 millimeters, it's what? A centimeter. That's quite an exposed tip. The more tip you've got, the more chance of you ultimately touching it somehow, or indeed touching the tip against a piece of earth metal and also starting a short circuit. Okay, so it's actually 2 millimeters. Okay, let's go back to the presentation. Only got couple more slides, and then we'll go into the live demo and see how that goes. So remember, always use safe isolation procedure. Always use safety lockouts. What we're talking about is your padlock. It provides safety for you and others. And I emphasize this again, do not work on it live, ever. Your life is worth more than that. Like I say, in most cases, if you think of an average 3-bed semi, which, you know, most housing stock in this country is, let's face it, it's 5 minutes to walk from the furthest bedroom upstairs, even into the garage where the consumer is, and turn that supply off. It's not worth it. Believe me, it's not. And the exam emphasizes that all the time. What's the correct procedure? What must you do in these circumstances? It's always turn off the power and isolate it. Keep that key in your pocket. That's another big exam tip. Where do you keep the key? On top of the consumer? No, you put it in your pocket. You don't give it to your mate. So, few oddball slides, but all related to the exam. Electric shock. The two ways you can receive an electric shock. One is coming direct contact with a piece of equipment, which is intended to be live. So, for instance, if you, I don't know what we got here. We just pulled up on the main screen so we can see it a wee bit better. There's a socket. Okay, generally speaking, that's the bit you see on the front. If we drop that socket down and expose the back here, clearly this brown cable is meant to be live. Okay, it is. Now, if I touch that, you know, drop that down and stuck my finger in there somehow, I was getting electric shock. It's not designed to do that because that's designed to be stuck in a wall. Okay. So how we get around live parts, which are meant to be live, we call basic protection. That's what we call putting things like barriers. And a barrier, that's a barrier. It's a plastic front to stop us touching those live parts. We can put them out of reach as such, they're very high. So that's what we call basic protection. When we've got the second part, where we've got fault protection, where we're talking about a piece of equipment which isn't normally live, but it could become live in a fault condition. The pictures there got a faulty microwave. Now, a lot of microwaves, most microwaves are actually metal or metal casings. If on that metal casing, obviously normally you touch it, you're not going to electric shock because it's not designed to be live. But if there was a fault in there and somehow that microwave became live, you touch it, you could get electric shock. Now, putting some out of reach is not an option. So you can't really use basic protection on that because you need to access a microwave. So what we have then, we call fault protection. So in other words, when there's a fault, we've put fault protection in. And those are things such as RCDs, MCBs, earthing, that little group all protect you from a fault. So that's what we call fault protection. So there's two different types, basic protection and fault protection. So what happens if you do receive an electric shock? Well, probably you wouldn't better do this because you might be on the floor having received the electric shock. But let's assume you're working with a colleague and they receive an electric shock. Well, the first thing you must do, if you can, is turn off the main switch. Now, in a lot of cases, the main switch is consuming it. You're working in a bedroom upstairs. You wouldn't better do that. So if you can't do that, you need to break contact. This is assuming this person's still touching a live supply. Like I said, these are all questions in the 2392. What's the procedure? What's the most likely thing you must do in event of an electric shock? You must break the contact between the source, i.e. the electricity, and the person receiving it. And it's made on there, say, use a conductive item like a wooden stick. I don't know about you, but I don't carry a wooden stick with me all the time. But what a good idea is, you've all got shoes on. Most building shoes are rubber soled. So I just kick the person in a nice way, and I kick, use the sole of your boot to push them off the live supply. Okay, you're not getting an electric shock because your rubber will insulate you, but it will get the person off that electric shock. Immediately then call for help. Now it's got on there, commence CPR. On a previous video I've just done, never do CPR or any other procedure from a health and safety point of view if you're not fully trained. You might do more damage than actually they've actually got. So unless you're trained, don't attempt something like CPR. Call 999 immediately. If you've got burns, you need to treat burns. Burns are easy to treat in most cases, but again, if it's really severe burns, in fact any burns, you need to get in touch with 999. Okay, as it says there, do not come into contact with the other person. If it's only a small burn, we've all burnt ourselves on pans and things while we're cooking. What you must do is put that burn, finger, thumb, hand, whatever it might be, put it immediately under cold water and run it for about 10-15 minutes. Okay, that'll take the heat out of the actual burn. Okay, little thing on there, it's got protect it from non-fluffy material, cover it in cling film. You see that a lot. People who have tattoos, for instance, they cover it in cling film. It just keeps that infection away from the actual infected area. Okay, if it's only a little burn, most people, like I said, run it thing, maybe just leave it. Obviously, if it's a severe burn, you must get them to hospital and deal with it that way. There's a few slides on here, and if you look in the top left-hand corner, these have all been supplied by the St John's Ambulance. I'm not going to go through these slides in any way. They're just for your reference, but it's well worth reading them. The key thing in all of these, if you listen to any organisation like the St John's Ambulance, if you're not trained in how to do CPR, or indeed, you see a lot of these like fibrillators now on high streets and places. If you're not trained on them, don't do it. Leave it for somebody who is trained. The recovery position, there's nothing to stop you doing that. It's a very simple procedure. But again, I'll let you read that at your leisure. So electrical testing, just to cover, because this leads in to the sessions we're going to do next week. Testing is separate to inspection. Testing is basically, or inspection should I say, bring the main screen up again. Inspection, when you're inspecting something, if you've done your own work, you probably wouldn't do the inspection phase because you know what you've done. You know you've put the right size cable in. You know you've corrected it correctly from a size of cable and the colors in the right order. You know you've run it in the right places. Generally speaking, inspections are where you're actually going and inspecting somebody else's work. So for instance, if you drop a socket, and you wouldn't drop every socket, you do a percentage of sockets, you're looking, for instance, just hold that very close up, are the cables terminated correctly? Is there any copper showing? Are they in the right terminals? Is it the right size cable? Those are the things you're looking for when you're inspecting somebody's work. It's a whole list of them. However, testing is actually when you're actually testing the installation. Now, that doesn't matter whether you've installed it or somebody else has installed it. You need to test it correctly. And there's a whole sequence of testing. And again, I'm not going to go through them in any great detail because that leads us on to next week's sessions. But big exam tip at the bottom there. Remember the sequence of these tests. Remember the sequence of these tests. Okay, next week we'll be going through these and actually carrying out all of these tests online, so you better see what they are. Okay, right. Before we go on for the next round of information, I'm going to go back here. I'm going to twist this round slightly. So what I've got, I want to demonstrate a single phase testing procedure for you, just to show how simple and quick it actually is. Now, obviously, I'm not on a workshop, so it's going to be a little tricky. There's my board supplying a little 2-socket radial circuit. In most instances, we would actually padlock this off first, okay? But in this instance, it's slightly tricky to do. So I'm going to take this board off. I'll bring this a little bit closer so we can actually see what we've got. We've got an RCD incomer, then we've got 2 circuits going out, supplying these sockets. So what we're going to do, we're going to isolate this RCD incomer so we can work on these 2 circuits. before we drop this off, it's not really designed to be turned off straight away under load conditions. So what is a good practice to do is actually turn all the circuit breakers off one by one. So it's taking the load off here. So when we turn this off, it's doing it under non-load conditions. For instance, if we had the whole house fully loaded, you could have, I don't know, 40, 50 amps going through this. If I suddenly turn that under that load, you get a lot of arcing going on inside that RCD. If you did that frequently enough, that would damage the RCD. Okay, so we just turn it off one by one. Obviously, if you had lots of them, you turn them off one by one. So when you come to turn off your main isolator or RCD incomer, it'll actually do it under non-load conditions. So now we've done that, what we must do is then put a padlock on it. So I'm just going to put that back over there slightly. As I said earlier, what we're going to do is use this little device, and this clips on to the RCD little toggle switch. So I'll pop this a bit closer up. So we're going to clip this on here. In fact, I'm just going to pop it down here for 1 second because it's a little bit awkward to do, but I'll show you once I've put it on. I'll show you obviously the end result. Okay. I said there are lots and lots of different devices we can use to isolate it. Obviously, this is on a board. It makes it much easier to actually do what I'm doing here. Okay, so it's just a little bit awkward to tighten that up. And I'll show you. All right. As you can see now, with that, it's got this little device. I can't even turn that on and off now. So once that's in position, we then, using our padlock, which we've got here, open up the padlock. Before we put the padlock on, we put the warning notice on there. I'm not going to fill it in. It's only a demo. So we pop that on there. And back to the installation. Pop that through. Pop it through. And then we can remove the key, put that in my pocket. And as we can see, that is now totally isolated. If anyone was coming along, they'd see the padlock on. Pop that down. Next sequence. Who's going to tell me what the next sequence is? Oh, thank you, George. As you know, we then need to prove, is the voltage indicator working? So let's pop that in there. And to show you, you see all the lights on, off, on. So we now know the voltage indicator is working. What do we do then? We test between, I'll actually put that back over there. Test between, and again, it doesn't matter what sequence, but what I like to do, if you think about it, if I put that onto the mains, if that was live, so we've got on the live terminal, if that was live, that end of here would be live as well. I think that's quite dangerous. Even though I know it's padlocked off and it's not, just in case, safety first, in my opinion. So what I like to do, I like to put it on the neutral first, which should be 0 volts. So the end of that tip should be 0 volts. Then I can test between live and neutral. Obviously, there's no lights coming up on here, which indicates it is 0 volts. I then take it off the live and off the neutral. Again, then I can test between earth, because that is 0 volts, onto the neutral. As you can hear, no lights, no buzzing, so we know that's 0. Then the final test is between earth and live. And again, 0 volts first. We now know this is dead against live. And again, that is 0 volts as well. So we now know we've done the 3-point test. That is completely isolated. What's the last bit we need to do? Correct. We need to retest the voltage indicator on the proving unit. Pop it in there. As we can see, it's still working. How long did that take? Not even a minute. It's very, very quick procedure. It's nothing difficult. And I said you'd be doing that on your practical testing for 2392, and you'll be asked many questions about it in your theory exam for 2392. Okay, nothing difficult about it at all. And that potentially could save your life and the life of others. So let's do it. Now, I'm going to put that one down. Proper Blue Peter stuff. And I've got a 3-phase board. Okay, now it's exactly the same, but as I told you earlier, it's got a few more points on it. So if you somehow mount that up there, will that stay? Yes, it will. Just move that around slightly. So I'm not going to do how we putting the padlock on or anything like that. I just want to show you the procedure. As I said earlier, as long as you do the 10 points, it doesn't matter what sequence you do it in. What I like to do, as I said, always put it on the safest terminal first. In this case, it's the earth. So I like to test between earth and then L1, L2, L3. Okay, that's 3 steps. And then I test between earth and neutral, which is step 4. And then between neutral, L1, L2, L3. So that's steps 5, 6, and 7. And then the only other steps then is between L1 and L2, L1 and L3, and in between L2 and L3. So you saw how quickly, obviously it's a little bit quicker here because I haven't done the padlock scenario, but even with a 3-phase board on 10 steps, it's very, very quick. Once you've got it isolated, it's seconds to do a full isolation procedure. Nothing scary about it, okay? It's very, very easy to do. Let's pop that down before it falls down. Okay, back to the PowerPoint. Let's move that back around there. So hopefully now you've got a lot of good information on safe isolation. If you haven't already booked on the sessions next week, please do, because it's a follow-on and you'll have a lot more detail on lots of different topics for your 2392. Safe isolation is part of it. There's a lot of other topics which we'll be running through next week. So just to re-emphasize again, when you come into the centres, you'll get no more further information from the tutors from the sessions. All the studying you're going to be doing is remote. Okay, so when you come into the centres, all you'll be doing is taking the exam. That means you need to have thoroughly studied for the exam before you take it. Otherwise, you're going to put yourself at a disadvantage. So you can watch this video and watch all the other sources of information, such as your smart screen units, such as your trades job mates, and such as all your revision books, which you're using currently for your TMAs. So watch these sessions over and over again, and don't underestimate the amount of work you've actually got to do. So this is just emphasizing the same thing. Remember, it's not just a matter of passing the mock exam. When you're doing the mock exam, you're going to be doing it at home. You've got all those resources. You could just look at all those and just pass it. But you probably, or you may not even understand any of it. You've just looked at the answers in books. And then when you come to do the actual exam, you potentially could fail it. You don't want that to happen. When you take that exam, you want to pass it first time so you can qualify as quickly as possible. Okay? So revise it over and over again. It's just not a matter of passing the mock exam. So when you're going to take the formal exams, at the moment, we don't know when the college is going to open. We're expecting further information in July, which in reality is next week. But at the moment, we don't know when that's going to be. And the government rules for education settings not just apply to us, it applies to all schools, colleges, and universities. So we're preparing you. So as soon as we get that go ahead, we can get you in the centres and you can pass those formal exams as quickly as possible, as soon as we get the go ahead from the government to reopen. So it's vital you use your time wisely, as always, to study all that material over and over again. Don't just study it for the mock exam, study it for the real exam. So what next? You can take your mock exam, but remember, it's not all a matter of passing it. Revise, Smart Screen, Trades Job Mates, all the trade books you've got, and indeed these revision sessions as well, as many times as you want, over and over again. So once you finish the current session on your centre study, then there'll be no further there will be further tutor marked assignments that you'll need to submit. Once you've submitted the relevant tutor marked assignment, that's the TMAs, then the next centre study material will become available automatically. So once again, thanks for tuning in. And again, just to reiterate, if you haven't signed in for next week, the test and inspection lit, please do. It's a great one. It's very thorough, and you'll get a lot out of it, which will help enormously for you passing your 2392 exam. Thanks for watching. Stay safe. I'll see you on the next time. Goodbye.